Hi, all. Welcome back to BRR Knowledge Center. And in this today's session, we'll talk about dynamic type in C sharp. So, so we were just used this dynamic keyword in a previous demonstration of reflection, right? So I wanted to, sorry. So I wanted to give you more clarity on dynamic type in C sharp in this session and how it is useful and where we need to use that and how it is differentiating static type declarations in C sharp. Before understanding a dynamic keyword in C sharp, let us first understand the different type of programming languages that exist in the current market, right? So broadly, programming languages can be categorized into two sections. Let me get into the notepad here for more understanding on programming languages right now we have in the market. So can be programming languages categorized into two types. So one is dynamic, second one is static. That means if I say it is my languages, right? In one side it is dynamic, and another side I have a static. This is what the languages are available in current market. So dynamic programming languages and strongly typed programming languages can be name it as static as strongly typed programming language for better understanding. Okay, the strongly typed programming languages are those programming languages where data type is checking actual happens at compile time, and dynamically typed programming languages are those languages where data type is checking is happens at runtime. So these can be named as strongly typed programming language, and this we can name it as dynamic, programming language, dynamic type programming language. Okay, so dynamic programming language and static programming language, right? Let me move this. These are strongly typed. These are dynamically typed. If you want it to be named or explained in single line of statement, I can tell you this is strongly typed, where it is checking actually what is happening at compile time. These are that means strongly it is recommended to check the compilation process very cleanly, that the type and the assignments are happening based on the declared type or not, and then it start executing. When it comes to dynamic programming, so it only appears and occurs at a compile time. Okay, let us take an example. If I declare a variable kind of integer, okay, let me go to my solution here. This is where my console application. Suppose if I want to declare a variable called number equal to some I say like bearer, right? So actually I've been declared it as an integer type, and I'm trying to assign as a string. So it will get any compile time error as shown in the below right here, saying that cannot implicitly convert type string to integer. This is compile time error because not yet run more, not yet in run mode, because I'm trying to compile it itself. When I compile it, it throws an exception, right? It's saying same message here. This is compile time. That means strongly typed. Okay. So I think we can see similar exceptions when you're trying to, assign it a different data type or different content to the left-handed declared data type. When both are same, then it's not don't have problem. But when they have a difference in this left-hand side and right-hand side, then you will get a problem in C#. So strongly typed programming languages are those programming languages where type checking happened during the compilation time. Okay. Now, but sometimes what happens is that you don't know the object data type until the application runs it, right? Sometimes, because if you wanted to integrate a third party kind of service and a library, and you are not having any documentation or kind of explanation, I mean description about the third party component, then there is a chance, there is a requirement to you that dynamically you have to write a program to access the fields and properties, right? If that is the case, you must understand like how it is going to be written in C#. So if that is the situation, that means that in the time of compilation you wanted to see all the stuff inside of library or inside of your component, so you don't know the data type actually, right? So in other words, you confirm the object data type during the runtime only, basically. So in that scenario, what you need to do is you need to bypass this compile time type checking logic, and only forcefully map should be checked in during runtime. You would like to go and invoke methods and properties of the objects in runtime only, right? So, but as a developer, you need to take an advantage of both approaches, because type checking is good thing for the developer because it is showing you the errors in the early stage before deployment or production, or before pushing the stuff into your repository or in the CI process. But again, you need to look at the other side of the programming, that when you don't know what is inside of library, that the particular variable, the method has been declared it, then you must go for a dynamic, right? So yes, during the compilation time, you need to bypass the type checking, but once the type is confirmed during the runtime, you need to ensure that type checking is happening. In other words, you would have something like dynamically, statically type benefits, and that is what dynamic keyword gives you, C# programming language. So it will bypass the compile time type checking, but once the data type is confirmed during runtime, then it will ensure that type checking is happening at runtime. So it will not completely, bypass the type checking, even you use the dynamic programming stuff here, but it only happens at the runtime. So not at the compile time, but definitely surely it will check the types, type checking is happening, even in dynamic or the static programming language. For example, if you want to declare a variable dynamically, you need to use the dynamic keyword. So let us say like about this, I'm just commenting this. So I'm going to use a dynamic keyword, right? Dynamic, and then I'll say str, then VRR. It's fine. So I used a dynamic keyword here, and you can see in the this statement here, dynamic str bearer. This thing will resolve during runtime using the complete concept called reflection. So during runtime, it will figure out exactly the data type of the str object. Okay, so you can see that here we are not getting any compile time error as well. So if you build an application, you will not get an error. Like let us say build application, I'll not see any error because Dynamic still accepting the stuff because it is stopping type checking while compiling your program. But that's Dynamic forcefully stop type checking in runtime, compile time. But when you run and compile, when after compile, when you run it, it will definitely check the type checking. Okay, so where are we? Yeah, so this is because during compile time it is not doing any kind of checking, but during runtime we need to ensure that things are being corrected. Let us say if I say this, I didn't get any error because it's a dynamic keyword, but but technically, it is a problem because you've been declared as a str, assigning it to as a string, and you're trying to increment that using str plus plus, right? It is impossible. But you declared with a dynamic keyword, it won't give you any problem at compile time. But when you run, you will get the problem. I'm trying to run it, I'll get a problem. So cannot be applied to operand of type string. Okay. So, so we are using a get type method. Basically, I think we'll do one thing. I think we'll see like what is the type being assigned at runtime. Console dot the right line of str dot get type. We'll see what is the type it is assigning it to runtime. Yep. Let me put a debugger toggle break here and see what is happening. Okay. So for me, it is displaying this thing. And when I press F10 here, right, it is showing me a system.string. That means it is assigning the type as system.string at runtime. So during compilation, it won't give you any time, but at runtime, we preserve the type of variable using a dynamic keyword, using reflection internally. So now I hope you understand the need of use dynamic keyword in C#. Let's see like and explore dynamic keywords in more detail. Okay, and just stop my program. So in C#, we have several built-in data types such as string, int, bool, double, date time, etc. So all these are static data types because so the type checking is happening at compile time. So meaning type checking and type safety are enforced at compile time. That means for these built-in data types. So for better understanding, please, I think write a program here. I'm just commenting this stuff. I'm declaring int is now kind of a 50. Int L equal to I. I think still I can assign it because both are in same data type, right? So I'm just printing this int I equal to I, right? And long L equal to, yeah. So dot read key. Console dot read key. When I compile, I didn't get any problem. When I run it, it will display no the actual type value being assigned. I equal to 50 and L equal to 50, right? So in this example, so we have declared an initialized integer variable called I with 50 value. And then we created a long variable called an I and initialized with variable of integer, right? The following, the given code will compile fine and runs without any issues. This is because the data type and conversion to a long data type without any data loss here. Why? Because the long data type has a bigger range than the integer data type, hence it won't give you a problem while running or compiling the program. So the C# compiler CSC allows this implicit conversions. Then we simply print the I and L values and console. Okay. Now let's use a reverse the data type. I'm just closing this. So what I'll do is I'll declare this as an integer, right? I'm declaring this as long. I'm doing a reverse process here. And this is still I'm declaring int L equal to I. Now you see a compile timer cannot implicitly convert. So as you can see, there is error because you are trying to assign a bigger data type value to a smaller data type value here. Right? The reason is long data type has much bigger range than integer data type, and there is a chance of data loss here. Hence, C# compiler does not allow these conversions and give a compile time error for the clarity to the developer. If you look at the compiler error message here, the second message says that because of a conversion, it is like issue conversion, like are you missing any cast or something? That means we can use an explicit cast if you wanted to convert a long data type to an integer data type. That's what the warning it is giving. If you're okay with that, I think you can convert to int. Now I'll not see any problem here, right? Because I've been explicitly converted this I into a integer. So if I run this, so it will give me the same values because I've been already converted. 50 is being assigned both I and L value. Okay, so this is one way of converting built-in data type values one to another data type. Now let's look at dynamic. So I'm going to remove this. I'm going back to desktop. And so dynamic keyword, I want to prefer another use a static string. I can do this, right? Here, if I say str saying some method, right? It will throw you a compile time error because it's a static data type. String doesn't have a kind of a method. This is what the compile time error. So when you try to run the above code, you'll get the error message, right? So this compile time checking of the code is called a static binding or early binding, and it's a good thing because we are able to catch the errors at compile time instead of runtime. That means early stage you will get all this stuff and you will fix it and you will deploy it in production. Now, if I do the same thing using a dynamic keyword, I'm just copying, I'm just commenting this stuff. If I declare this as dynamic, okay, it won't give you the problem because you have been declared as a dynamic, but still you will get a problem at runtime because it doesn't have method instead of str, right? So the thing was this dynamic keyword using to stop or bypass compile time type checking and safety, but at a runtime it will again do the same thing. Okay, so with static C# code, type checking and type safety are enforced at compile time, and with dynamic C# code, type checking and type safety are enforced at runtime. For better understanding, this is how it is happening. Okay, so I hope you understand the differences between dynamic and static programming languages and data types. Let me write down another example very clearly. So dynamic str equal to dynamic keyword in C#. So I'll print this into console. Okay. Type is str dot get type and value is str. What is happening? Okay. Type is str dot get type and value is str. That's fine. Now I'll declare another variable dynamic I equal to 50 right line of type is I dot get type and value equal to nothing I. So for both prints I'll hold this for key press right key. So if you look at here the first example, okay, based on the value at runtime it will decide the type of str as a string. So based on the value at runtime, it will decide the type of str as string, right? And here, based on the value at runtime, it will decide type of I as int. So one is at runtime, another one is at runtime, compile time. This is for compile time because dynamic, and this is at runtime again. Based on assigned value. Okay. When I run this, it will tell you this is type is system string, values dynamic keyword. So this type is integer, value is 50. Okay, so based on the assigned value, it will decide the type at runtime and then enforce the type checking and type safety at runtime with this example. So it will at runtime it will decide the type of str as a string here, and it will define the compile time data type. Okay, so this is all about how to use a dynamic keyword and static built-in data types. So I hope you understand the purpose of dynamic keyword. So basically, for to write a dynamic program and assigning and bypass the type checking and safety at runtime. Okay. Thanks for listening this video, and please subscribe this channel for more videos. Thank you.